So now when you look at the inductive reasoning means, it's basically you're analyzing some pattern, what's happening to the next, or any patterns you see. That's kind of like inductive reasoning too. So let's look at it one question. So you can answer the question and also tell me what do you think happening out there. All right, it's coming up. All right, go ahead and read the question for me.
Describe how to sketch the fourth figure in the pattern. Then sketch the fourth figure.
Okay. So what do you think?
You have to do two. I mean, you have to double up each one.
Mm-hmm.
Actually, no, so you have to add 2 to it.
Okay. All right.
And then the figure here. 4 is going to be 8.
Okay, so there's a circle. So you can go ahead and then do this, or maybe I'll put an empty one.
But I can't write on it.
You can't write it? Mm.
Okay, I mean, I can, but it won't be
or just explain it to me.
Like, gonna be...
Right.
Difficult to draw.
Yeah, it is difficult to draw. Okay, I understand that. But explain it to me.
So figure 1 is like, it's 1, 1, 1, but there's the non-shaped pieces or the total pieces. You always have to add 2, and it's basically all even numbers.
Right. Okay. So here, number of pieces, like they cut it into pieces. 2, 4,
6, and then the next one's gonna be 8.
2, 4, 6, and the next one has to cut into 8 parts. Okay.
You just have to shade in 1.
That's right.
Cut everything else as 1.
Right. Exactly. So it's basically this is, you can put it 1/2 fraction, and this is 1/4, and this is going to be 1/6. The next one is going to be 1/8.
Yeah.
Does that make sense? That's good. Let's go ahead and read the question. Go ahead and read the question.
Oh, I already know the answer to this.
Okay, tell me the pattern then.
Basically, you have to add 3 to the next one.
Add 3.
Sorry, multiply 3. Multiply 3.
Okay, that's good. So basically the pattern is -7, -21, -63. You're right. The rule is multiply
3
by 3.
Not -3 because...
Yeah, just positive 3 because his negative is out of there. That's good. Okay. Good work. Good work. Put a star for you. Good job.
Describe the pattern in the numbers 5.1, 5.3, 5.5, 5.7 to write the next 3 numbers in the pattern. Oh, this is really easy.
5.01, 5.02.
You have to add 0.02.
So the rule is here, add 0.02.
Or 0.02.
Yeah, 0.02. Either way, you can write it that way too. Or
0.2.
Not 0.2 though.
Wait, but it kind of makes sense.
0.2 means this is
20. Oh yeah,
that's a 20 cents, and this is 2 cents. Okay. Good. The conjecture is basically it's an unproven statement that's based on an observation. Okay. So conjecture means unproven.
Unproven?
Statement that is based on an observation.
Oh.
Like you saw that one, but it's not proven. So that's called conjecture.
Like so alien.
Yeah, could be. We can say that too. That's just by observation, but we don't know if really they exist or not. So that's a good one. So what we can use is we can use the inductive reasoning to make it sense of these problems. Given 5 collinear points, make a conjecture is about the number of ways to connect different pairs of the point. So think, and then tell me what you think about it. And this question says 5 collinear points. What's a collinear means?
Doesn't it mean two lines connected? Or is it plane?
No. Collinear points means the points
Isn't
on the
it
same line.
two points on a line?
Right. Where all the points in the same line is called collinear. Okay.
I remember that one.
Right.
Or what's the other one?
Coplanar.
Yeah, isn't that the one with the 2 points on a plane or something?
All the points on the same plane, yes. Let's say for this one, number of points, we can try about number of points. And then we can see, we can draw a picture for this. And also we can see a number of connections we can make. Number of connections. So let's say I have 1 point. How many connections can you make?
You have 1 point.
Yeah.
1 connection.
There's no connection because there is not another point to connect.
Oh yeah.
So if I have a 2 points.
With 2, then you can connect 2 points.
2 points, or how many connections can you make? 1. Because you can just join that. That's 1 connection. So if I have a 3 points.
2 or no?
How many connections can you make?
1.
1? I think I can make 1, 2.
This is kind of confusing.
3. Okay.
Wait. So it's 2.
So I can make a 3 connections. Like first one is 1, and then 2, 3. Okay. So it's basically we're kind of like exploring different points and see how many ways we can connect. Let's say I have 4 points. How many ways we can connect these points? First one is 1, 2, 3.
3.
And then
4.
I can say
4.
This can be 5, and this 2 can be 6.
6. So 6.
6. Okay. Now tell me how many is going to be 5.
How can it be 5?
You can do it on the paper. See if you can come up with it. How do you get the 8?
I did 1, 2, 3, 4, 5, and then I went on tops. 6, 7, 8, 9. Oh, it's 9.
Okay. So can we, since we kind of like making some observations right here, but can we find a pattern from here? Like from here to here, what do you do?
1.
From here to here?
2 plus, 3 plus, 4 plus, it's 10.
That's right. So they have to have 10 connections here. So let's check.
But it's not proven.
Yeah, but let's see. 1, 2, 3, 4. From here, 5. From here, 6. From here, 7 and 8, 9, and 10. Okay, so like that. So as number of the points, collinear points goes on, you can come up with more different ways to add on to this too. Okay.
Yeah.
Right. Before we move on, let's do some practice questions.
There's always a pattern for everything.
That's right. So it's always, you can see anything in the world, is almost everything is like follows a pattern. If you look at a petals of a flower, it follows a pattern. You know, a lot of things follows a pattern.
Except weather, because this weather's kind of unpredictable.
I mean, I don't know, could be a pattern there, right?
Like there can be tsunami, and then immediately after that there can be a hurricane.
It's true, could be. All right. On this one, I don't want you to sketch the next pattern, but I want you to tell me the number of blocks in the next pattern. I want you can write it. It's 1. Just
So
write down the
one
number of
and
blocks.
1, 2, 3, 4, 5, 6. So there's 6 in the. So I think it might be 5 plus.
We'll check it. Okay.
Wait,
What is
is
the rule?
number 416 the answer?
So what is the pattern? We find it.
5 plus in the for number 4.
Okay, let's check it. This is 1. How many blocks here?
6.
That's right. That's good. How many blocks here?
11.
That's right. So you add 5 here, then add 5 here. So it's going to be add 5 here, right? So the next one is going to be 16 blocks. So the pattern is add 5. Okay. That's
Sometimes you can add 5 minus 2, add 5 minus 2.
Yeah. All right. So the next one, let's find out the next pattern in these two questions, number 6 and 7. Number 6 is good. Okay, add 4 here, add 4 here, add 4 here. Okay.
Oh wow, number 7's kind of tough, but I think I know the answer.
All right, let's try that.
12 equals 48. 48 times 4 equals 192. And 192 times 4 equals 768.
Very good. So the pattern basically times, I can say the rule, it's times 4. Okay, good. Very good. I like that. We're making a kind of like a testing a conjecture. Is it true all the time? It's only true on sometimes, like that.
Those things, like sometimes like for angles.
Yeah. Sometimes it works or not. So that's what we're gonna look at it right now. Okay. Go ahead and read the question.
Numbers such as 3, 4, and 5 are called consecutive numbers. Make and test a conjecture about the sum of any 3 consecutive numbers.
So
what are consecutive numbers?
Consecutive means next to each other.
Oh.
Consecutive means next to each other, next numbers.
Okay, this is gonna be tough, but I think I can do it.
Okay, so go ahead and try that, and then we'll come back to this.
3 plus 4 plus 5 has is an even number, or the sum is an even number.
Okay, that's a good observation. What else do you think?
Number.
It is a number.
3 plus 4. It's a number.
That's true. I agree. But again, can you be more specific? I know it could be any numbers you obviously.
It's a positive number.
Okay, what if you take a negative number? Negative consecutive integers, right?
Well, but they're not usually. Do they count?
Yeah, that counts. But can you come up with some other pattern? Look at it. All right, let me get you something up there. Okay.
They're integer.
Yeah, I agree. I like that. So if I look at this one, 3 plus 4 plus 5, what I get?
What did you say? Oh, 12?
12, right? So 12 is there. Okay, just keep there. I'm going to take another number. 7 plus 8 plus 9. How much is that?
24.
24. Okay. I'll take one more to make a sense. 10 plus 11 plus 12.
32. I mean 30 or 33.
33. Okay. So by using this, can you come up with any pattern? Do you see anything up there? Matching with the numbers. So the 12, I can write, how many numbers we have here? 3 numbers. And what's the middle number here?
They're each they each can be divided by 1.
That's true, but I want you to look at it carefully. So these are consecutive numbers, and then there are 3 of them, but the middle number is 4, right? So I can I say is like 4 times 3, this is?
They each have 3 as in
Right. So it's if you look at it, the next one right here, the middle number is 8. 8 times 3, that's 24.
they each have 3 as a factor.
Yeah, that's true. And then last one is 11 times 3. That's it. The middle number times 3 gives you that sequence. Does that make sense?
Mm-hmm.
So your conjecture is going to be, I can write a conjecture. Sure. It's basically,
Nothing.
what is it? Repeat again?
No, nothing. It's just I was gonna ask something, but I already knew the answer to the question.
Oh, okay. So the conjecture is basically the sum of 3 consecutive integers. The sum of 3 consecutive integers is 3 times the second number.
Mm-hmm.
Do you agree on that?
Mm-hmm.